Imagine trying to build a house that needs to last 200 years using nothing but an axe, a saw, and your bare hands. Just you, some trees, and the very real possibility that if you mess this up, your family might not survive the next winter. That's exactly what early American colonists faced, and what they accomplished might just change how you think about craftsmanship forever. While we're busy complaining about crooked picture frames and wobbly IKEA furniture, these folks were creating joints so precise they're still holding houses together after 4 centuries. They were splitting wooden shingles by hand that outlasted modern roofing materials. They were mixing wall materials from scratch that provided better insulation than some contemporary homes. We're talking about people who turned raw forest into weatherproof shelter using techniques so ingenious that modern engineers are still studying them. They didn't just build houses, they invented entirely new ways of working with wood, stone, and clay that would influence American construction for the next 300 years. But here's what's really mind-blowing. They did it all without a single nail, screw, or piece of metal hardware. Every joint, every connection, every structural element was held together by nothing more than precisely cut wood and an understanding of physics that would make modern architects jealous. If you've ever wondered how people created things that actually lasted before planned obsolescence became a business model, you're in for a treat. Hit that subscribe button because we're about to dive deep into craftsmanship techniques that put modern construction to shame. With the community assembled and the timber prepared, colonial builders faced a challenge that would determine whether their house lasted decades or collapsed within a few years, creating a solid foundation. Unlike medieval peasants who often just dug holes and stuck posts directly into the ground, American colonists had learned from European mistakes and developed more sophisticated foundation techniques. They had to. American weather was often more extreme than what they had experienced in Europe, with harder freezes and more dramatic temperature swings that could destroy poorly built foundations. The most common approach was the stone foundation, but finding the right stones was its own adventure. Colonists needed stones that were large enough to provide stability, flat enough to stack properly, and hard enough to withstand decades of freeze-thaw cycles without cracking. In New England, glacial activity had conveniently scattered massive boulders across the landscape. These field stones became the building blocks of colonial foundations. The problem was that they were rarely the right shape or size, which meant a lot of time spent with hammers and chisels, trying to convince stubborn rocks to become useful building materials. The foundation building process started with digging a trench around the perimeter of the planned house. This trench needed to be deep enough to get below the frost line, the depth at which soil freezes in winter. In northern colonies, this could mean digging down 3 or 4 feet, which was backbreaking work with only shovels and picks. Once the trench was dug, colonists would lay the largest, flattest stones as the base course. These foundation stones often weighed hundreds of pounds each and required multiple people to position properly. The goal was to create a level platform that would distribute the weight of the house evenly. But here's where colonial builders got really clever. They didn't just stack stones randomly. They developed techniques for fitting irregular stones together like a 3-dimensional puzzle. Smaller stones filled gaps between larger ones, and everything was carefully positioned so that the weight of upper stones helped lock lower ones in place. Some colonists used a primitive mortar made from lime, sand, and water to help hold foundation stones together. Lime was made by burning limestone or oyster shells in kilns, a process that required significant time and fuel, but produced a binding agent that could last for centuries. In areas where good stone was scarce, colonists got creative with alternative foundation materials. Some used large wooden posts set on flat stones to keep them off the ground and prevent rot. Others created foundations from brick, though this required access to clay and the knowledge of brick-making techniques. The foundation also had to include provisions for drainage. Colonial builders learned quickly that water was the enemy of any structure. They would often include drainage channels or small gaps in the foundation to allow water to flow away from the house rather than pooling around the base. With foundations set and community gathered, the real magic of colonial construction began. Timber framing. This wasn't just carpentry. It was 3-dimensional puzzle solving that required mathematical precision, engineering knowledge, and the kind of spatial reasoning that would make modern architects jealous. Colonial timber framing was based on European techniques, but American builders adapted and improved these methods to work with local materials and conditions. The basic principle was to create a skeleton of heavy wooden beams that would support the entire structure, then fill in the spaces between these beams with walls. The heart of timber framing was the joint. Without metal fasteners, nails were expensive and screws basically didn't exist. Colonial builders had to create connections that relied entirely on precisely cut wooden joints held together with wooden pegs. The mortise and tenon joint was the workhorse of colonial construction. This involved cutting a rectangular hole, the mortise, in one beam and shaping the end of another beam, the tenon, to fit perfectly into that hole. When done correctly, these joints were incredibly strong and could last for centuries. But creating perfect mortise and tenon joints with hand tools was an art form that required years to master. The mortise had to be exactly the right size. Too small and the tenon wouldn't fit. Too large and the joint would be weak. The walls of the mortise had to be perfectly square and smooth. The tenon had to be shaped with mathematical precision. Colonial builders used a variety of specialized tools for this work. The mortise chisel was designed specifically for cutting the rectangular holes. Tenon saws had fine teeth for making precise cuts. Wooden mallets drove chisels without damaging the handles. Different joints served different purposes in the frame. Dovetail joints, which were wider at one end than the other, prevented beams from pulling apart under stress. Scarf joints connected two beams end to end when a single piece of timber wasn't long enough. Lap joints overlapped two beams and were secured with wooden pegs. The wooden pegs, called trunnels, tree nails, were crucial to the entire system. These were typically made from hardwoods like oak or hickory, shaped into round or square pegs that fit tightly through holes, drilled through overlapping joints. When the wood dried and shrank slightly, these pegs became even tighter, creating connections that could last for centuries. The precision required for timber framing meant that colonial builders had to be part carpenter, part mathematician, and part engineer. They had to calculate loads, understand how different woods would behave as they dried and aged, and visualize complex three-dimensional structures before they built them. Many colonial builders used a system of proportional measurements based on the human body, the width of a thumb, the length of a foot, the span of outstretched arms. This created buildings that felt naturally proportioned and comfortable to inhabit. With the timber frame standing strong, colonial builders faced their next challenge: creating walls that would keep out wind, rain, and the occasional curious bear. Unlike their medieval counterparts who had perfected wattle and daub over centuries, American colonists had to adapt old techniques to new materials and much harsher weather conditions. The most common wall system in early colonial America was called nogging, filling the spaces between timber frame posts with whatever materials were locally available. But here's where things get interesting. Different regions developed completely different approaches based on what they could find and what worked best in their specific climate. In New England, colonists often used a technique called brick nogging. They'd fill the spaces between timbers with bricks laid in clay mortar. This created walls that were incredibly durable and provided excellent insulation against those brutal New England winters. The problem was that making bricks required clay, fuel for kilns, and knowledge of brick-making techniques that many colonists simply didn't have. So they got creative. Some New England builders used what they called cat and clay, a mixture of chopped straw, clay, and small stones that was packed between the timber posts. It sounds primitive, but archaeological analysis of surviving colonial walls shows this technique was surprisingly effective at keeping out both weather and pests. In the mid-Atlantic colonies where stone was more readily available, builders often used fieldstone nogging. They'd carefully fit irregularly shaped stones between the timber posts, using clay mortar to fill the gaps. This created walls that were practically indestructible. Some of these stone-nogged houses are still standing today over 300 years later. But perhaps the most ingenious wall system was developed in areas where both stone and clay were scarce. Colonial builders created what they called plank walls, thick wooden boards fitted tightly between the timber posts. These boards were often cut from massive old-growth trees and could be 2 or 3 inches thick. The real innovation came in how they sealed these plank walls. Colonists developed a technique called caulking, driving strips of oakum, loose hemp fibers, into the gaps between boards, then sealing everything with a mixture of pine pitch and animal fat. It was basically the colonial version of weather stripping, and it worked remarkably well. The thickness of colonial walls was impressive by modern standards. While today's houses might have walls that are 4 to 6 inches thick, colonial walls were often 12 to 18 inches thick. This wasn't just for insulation, though it certainly helped with that. Thick walls also provided thermal mass, absorbing heat during the day and releasing it slowly at night. But wall construction wasn't just about keeping the weather out. Colonial builders had to consider fire safety, pest control, and even defense against potential attacks. Some frontier houses had walls thick enough to stop musket balls, with small openings that could serve as firing ports if necessary. Now, if you think colonial wall construction was impressive, wait until you hear about their roofing solutions. This is where American ingenuity really started to shine because colonists had to solve a problem that European builders rarely faced: how to create roofs that could handle massive snow loads, driving rain, and the kind of weather extremes that could destroy traditional thatched roofs in a single season. Thatch, which had worked reasonably well in Europe's milder climate, was basically useless in much of colonial America. A thatched roof that might last 20 years in England could be destroyed by a single harsh winter in Massachusetts. Plus, thatch was a fire hazard that colonial communities simply couldn't afford. So American colonists invented something that would revolutionize roofing: the wooden shingle. Now, this might not sound like a big deal to us, but wooden shingles were a genuinely innovative solution to a complex engineering problem. The process of making shingles was an art form in itself. Colonists would select straight-grained cedar, oak, or pine logs and split them into thin, flat pieces using a tool called a froe. Each shingle had to be precisely the right thickness. Too thick and they'd be heavy and expensive. Too thin and they wouldn't provide adequate protection. The real genius was in how these shingles were installed. Unlike modern shingles that rely partly on adhesive and metal fasteners, colonial shingles were held in place entirely by their own weight and the way they overlapped. Each shingle covered about 2/3 of the shingle below it, creating multiple layers of protection against water infiltration. But here's what made colonial roofing truly impressive: the pitch. Colonial builders learned that in areas with heavy snow, roofs needed to be steep enough to shed snow quickly, but not so steep that the shingles would slide off under their own weight. They developed a standard pitch of about 45 degrees that proved to be nearly perfect for American conditions. The installation process required incredible precision. Each shingle had to be positioned exactly right, with consistent overlap and proper alignment. A single misplaced shingle could create a leak that would eventually rot the entire roof structure. Colonial roofers developed specialized tools for this work. The shingle hatchet had a sharp blade for trimming shingles to size, a hammerhead for driving nails, and a gauge for measuring consistent overlap. The draw knife was used to smooth and shape individual shingles. Some regions developed their own roofing innovations. Colonists created shake roofs, thicker, hand-split wooden pieces that were even more durable than regular shingles. In coastal areas, they sometimes used specially treated pine shingles that could resist salt air corrosion. The longevity of colonial wooden roofs was remarkable. A well-built cedar shingle roof could last 50 to 75 years with minimal maintenance. Some colonial roofs installed in the 1600s were still protecting houses well into the 1800s. With walls up and roof on, colonial builders turned their attention to creating livable interior spaces. This is where the differences between colonial and medieval construction really become apparent, because American colonists were dealing with much larger temperature swings and had access to different materials and techniques. The first challenge was flooring. Unlike medieval peasants who often made do with packed earth floors, most colonial houses had wooden floors from the beginning. This wasn't just about comfort, though wooden floors were certainly more comfortable than dirt. It was about practicality in a climate where ground moisture and freezing could make earth floors unusable for months at a time. Colonial floor construction was surprisingly sophisticated. Builders would lay heavy wooden beams called sills on top of the stone foundation, then install smaller joists perpendicular to these sills. Wide wooden planks, often cut from single large trees, were then nailed to these joists to create the floor surface. The planks themselves were impressive. Some colonial floorboards were 18 to 24 inches wide, much wider than anything you'd find in a modern house. These came from old-growth trees that were massive by today's standards. A single pine tree might yield enough wide boards to floor an entire house. But creating level floors with hand tools was incredibly challenging. Colonial builders used a tool called an adze, basically an axe with the blade perpendicular to the handle, to smooth and level floor joists. They also developed techniques for using wooden wedges and shims to adjust the height of individual joists until the entire floor was level. Interior walls in colonial houses served different purposes than modern walls. Since most colonial houses were essentially one or two large rooms, interior walls were often movable partitions that could be reconfigured based on the family's needs. Some families would set up temporary walls during winter to create smaller spaces that were easier to heat. The most important interior feature was the fireplace and chimney system. Unlike medieval houses with their central hearths and smoke holes, colonial houses had proper chimneys that drew smoke up and out of the living space. This was a massive improvement in both comfort and safety. Colonial chimney construction was an engineering marvel in its own right. The chimney had to be large enough to draw properly, but not so large that it would steal all the heat from the room. It had to be built with materials that could withstand extreme heat without cracking or collapsing. Most colonial chimneys were built with stone or brick using clay mortar that could handle repeated heating and cooling cycles. The interior of the chimney was often lined with fire-resistant clay or specially selected stones that wouldn't crack under extreme heat. The fireplace opening was carefully proportioned to maximize heat output while minimizing smoke problems. Colonial builders learned that the width of the fireplace opening should be about 10 times the area of the chimney flue for optimal performance. As colonial houses neared completion, builders turned their attention to the details that would make these structures not just functional, but comfortable and durable for generations to come. This is where the craftsmanship really showed, because these finishing touches often determined whether a house would last 50 years or 500 years. Window installation was one of the most challenging aspects of colonial construction. Glass was expensive and difficult to transport, so many early colonial houses had very small windows or no glass windows at all. Instead, they used oiled paper, thin sheets of horn, or wooden shutters to cover window openings. When glass was available, it came in small panes, usually no larger than 6 by 8 inches. These small panes were held in place by thin strips of lead called came, creating the distinctive diamond-paned windows we associate with colonial architecture. The lead came was flexible enough to accommodate the slight irregularities in hand-blown glass while providing a weatherproof seal. Door construction was equally important and challenging. Colonial doors had to be strong enough to provide security, well-fitted enough to keep out weather, and durable enough to withstand decades of daily use. Most colonial doors were made from thick wooden planks held together with wooden battens and secured with hand-forged iron hinges. The hardware for colonial houses was almost entirely handmade by local blacksmiths. Door latches, hinges, nails, and other metal components were forged individually, which meant that no two pieces were exactly alike. This hand-forged hardware was often stronger and more durable than modern mass-produced alternatives. Interior finishing work included smoothing and sealing wooden surfaces. Colonial builders used a variety of techniques to protect wood from moisture and wear. Some surfaces were treated with linseed oil, which penetrated the wood and provided long-lasting protection. Others were painted with milk paint, a mixture of milk protein, lime, and natural pigments that created a durable, attractive finish. The final step in colonial house construction was often the installation of built-in furniture. Since furniture was expensive and difficult to transport, many colonial houses included built-in benches, storage chests, and sleeping platforms. These built-ins were integrated into the house structure and could last as long as the house itself. What really set colonial houses apart from their European predecessors was how well they were adapted to survive American weather extremes. Colonial builders learned through trial and error, and probably more than a few collapsed roofs, how to create structures that could handle everything from blizzards to hurricanes. Winter preparation was crucial. Colonial families would spend the fall months preparing their houses for the harsh months ahead. This included banking earth or straw around the foundation to provide extra insulation, checking and repairing any gaps in walls or roofing, and stockpiling massive amounts of firewood. The amount of firewood required to heat a colonial house through winter was staggering. A typical family might burn 20 to 30 cords of wood during a harsh winter. That's roughly equivalent to 40 to 60 full-sized pickup truck loads of split wood. Gathering and preparing this much fuel was a year-round job that involved the entire family. Colonial houses were designed with winter heating in mind. The central chimney wasn't just for cooking, it was a massive thermal mass that absorbed heat during the day and radiated it back into the house at night. Some colonial chimneys weighed several tons and could store enough heat to keep a house warm for hours after the fire died down. Summer presented different challenges. Colonial builders learned to design houses that could stay cool during hot, humid summers without air conditioning. This included features like cross-ventilation, high ceilings in some rooms, and strategic placement of windows to create cooling breezes. Some colonial houses included summer kitchens, separate buildings where cooking could be done during hot weather without heating up the main house. This was especially important in southern colonies where summer temperatures could make indoor cooking unbearable. The next time you're frustrated with a home improvement project or complaining about construction delays, take a moment to think about those early American colonists. They managed to create comfortable, durable homes using nothing but hand tools, local materials, and an impressive amount of determination. These weren't just shelters. They were engineering marvels that had to protect families through brutal winters, scorching summers, and everything nature could throw at them. The fact that many of these houses are still standing today, centuries later, is a testament to the skill and ingenuity of their builders. What's really remarkable is how these colonists took European building techniques and adapted them to create something entirely new, construction methods that were perfectly suited to American conditions and materials. They didn't just survive in the New World, they thrived, creating homes that were often more comfortable and durable than what they'd left behind in Europe. The ingenuity of early American colonists goes far beyond just house building. They revolutionized everything from farming techniques to food preservation methods. If you enjoyed learning about colonial construction, you'll definitely want to check out our upcoming video on how colonists developed and perfected these methods in their time. Be sure to subscribe for more incredible stories of human survival and innovation from colonial American history.